Hi, welcome to 6.2. We're going to talk today about trigonometric functions of acute angles. Just to recall, an acute angle is an angle that's less than 90 degrees. So let's just say that. Acute angle. It's an angle with a measure of less than 90 degrees, which is also pi over 2 radians. Okay, it does come down here as well. The 6 basic trig functions. Let's start off here. Here's a right triangle. This is a right triangle. It has a right angle down here. That's 90 degrees or pi over 2. And then here's an angle we're discussing. In relation to where this angle is here, this theta, this side is opposite the angle. This is the side opposite the angle. This side down here it's right next to the angle. It helps make up the angle. It is adjacent to the angle. This side that's opposite the right angle, this side is the hypotenuse. So the hypotenuse is opposite the right angle. The opposite side of the angle is over there. And down here is the adjacent side of the angle. So this is important in the context for what we're going to talk about when we talk about sine, cosine, tangent, also cosecant, secant, and cotangent. Assume that theta is one of the acute angles less than right angle. We talked about that in a right triangle. It's an acute angle. So we have, remember, we have 3 angles in the triangle. That's the right angle here. That's acute, and this one's acute. Means it's less than 90 degrees. Let the ADJ stand for adjacent, and OPP stand for opposite. So the adjacent side and opposite side. That's what those are going to stand for. The side adjacent to the theta and opposite the theta. Let HYP stand for the length of the hypotenuse of the right triangle. So then the sine, this is how you spell it out. We abbreviate with SIN. Sine, cosine, we abbreviate with COS. And tangent, we abbreviate with TAN. Sine, cosine, and tangent of the angles are going to be the following. Sine is the opposite side over the hypotenuse. So here's our angle theta. Here's the opposite, hypotenuse, adjacent. Sine is the opposite over the hypotenuse. This length over that length. Cosine would be the length of the adjacent side over the hypotenuse. These are just numbers we'll put. And tangent is the opposite side over the adjacent side. To extend this a little bit, we have cosecant, secant, and cotangent. So assuming that theta is one of the acute angles in the right triangle, then the cosecant, secant, and cotangent, and we abbreviate with this, cosecant is CSC, secant is SCC, and cotangent is COT. They are the reciprocals, respectively, of sine. So cosecant is reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. That is to say that cosecant is 1 over sine theta, which is the hypotenuse over opposite. Secant is 1 over cosine, which is the hypotenuse over the adjacent side. And cotangent is 1 over tangent, which is the adjacent side over the opposite side. So with all of that in mind, all those definitions, we're going to look at this triangle here. So use the information contained in the figure to find the values of the 6 trigonometric functions. Rationalize all denominators. When you look at this, you say, hey Jeff, we got 2 sides, we're missing the third. How can we get the third side? Well, we can use the Pythagorean theorem. If we call this side C, we'd have 5 squared plus 12 squared, here's our 12 squared, equals C squared. C is the hypotenuse. So 25 plus 144 equals C squared, or 169 equals C squared, so C would be 13. Now we're talking about this angle up here. So we're first going to find sine theta, then cosine theta, then tangent theta. Then we'll find cosecant theta, secant theta, and cotangent theta. So this is our angle. The side opposite is 12, and the hypotenuse is 13. So sine would be 12 over 13. This is our angle. The adjacent side is 5, and the hypotenuse is 13. So cosine is 5 over 13. Given this angle, the opposite side is 12. I'm doing tangent now. Opposite over adjacent, 12 over 5. Now we're going to go on to cosecant. Now cosecant is just the reciprocal of sine. It's the hypotenuse over the opposite side. So 13 over 12. Secant is the reciprocal of cosine, so it's going to be the hypotenuse over the adjacent side. And cotangent is the reciprocal of tangent, so it's going to be the adjacent side over the opposite side. So feel free to pause if you want to write all that down. You want some more time here. And we're going on to example 2. Evaluate the expression using a calculator if necessary. Now, the calculator of my choice is the TI-89, and I'll be showing you more about that. And there'll be some videos about how we use the TI-89, but here, for the sake of this, I just have my Casio FX260 solar calculator. So it says evaluate the expressions using a calculator if necessary, cosine and tangent of pi over 7. So we're going to do cosine of pi over 7, and we'll do tangent of pi over 7. And we're going to need our calculators for this. Now mine's in degree mode, so I'm going to have to switch it over, and I will be happy to show you guys how to do some mode switching of your calculators. Okay. That didn't do anything. There we go. So cosine of pi over 7. So I'm going to type in cosine. Okay, that's not quite what I wanted. So I put in my pi over 7, I hit my cosine button, and what do we come up with here? 0.900969. 900,969. Then we'll do tangent of pi over 7. And that's going to be 0.8. Oh, it didn't do my, sorry. One more time. Sorry, it's 0.481575. Now, I know you science majors are probably getting a little uncomfortable here because of my significant digits. I'm okay with it though, so sorry. Now we'll do cosine of a degree measure. So I'm going to go back to degrees for my calculator. I got to go to mode and do 4. There we go, back to degrees. So now I'm going to just type it in 28.37, doing cosine of that. And I get 0.879897. Now, I typically would go to 4 places if this is like a homework problem for me. So I might go to that, but 4 places is good with me. 3 would be the least. I wouldn't go to 2. Okay, now there's another notation, and this happened to me the other day. I was using my GPS. I was trying to find something. I was driving around Las Vegas, and I knew where I was supposed to go, somewhere at UNLV, but I didn't know where at UNLV I was supposed to go. I knew the building name, but I didn't know where it was. So I called a friend up. I said, oh, I'm kind of stuck. I'm driving around Vegas, and I can't find this building. And so my friend looked it up on the computer and sent me the coordinates for my GPS. Really kind of cool. I dialed it in and was able to find, well, except for the one thing. Degree, minute, second notation. My GPS is in degree, minute, second notation. Hers was in degree decimals. So I had to make a little conversion there and switch the settings. But it worked pretty cool. What is the difference though? Because a lot of people don't know these differences. So if you ever use a GPS that has the coordinates, the longitude and latitude of things, this is an important difference. Okay, in the context of angle measures, 1 degree, or sorry, this is 1 tick mark, means 1 minute, is 1/60th of a degree. That is that there are 60 minutes is 1 degree. 60 minutes in a degree. Now these 2 tick marks means seconds. So 1 second is 1/60th of 1 minute, which is 1/3600th of 1 degree. So you could also look at that as 60 seconds equals 1 minute. We know that from our time system. Also, 3,600 seconds equals 1 degree. And we know 3,600 seconds is 1 hour. So convert each of the expressions from degrees, minutes, seconds, that's the DMS notation, to just the decimal notation. So round off answers to 4 decimal places. Let me scroll this up a little bit so we have room to work. By the way, it worked really well to be given those coordinates, and I, like I said, dialed it in, and I realized the building was like right in front of where I was driving. So I was able to park the car and get to my meeting. Okay, so we have 256 degrees, 12 minutes, and 1 second. So first of all, we're going to convert 12 minutes times 1 degree over 60 minutes. And that's going to be 0.2 degrees. And then we have 1 second. 1 second times 1 degree over 3,600 seconds. And notice seconds on top, seconds on bottom. They're going to cancel. Before I had minutes on top, minutes on bottom. They cancel. So I have 1 second, and that comes out to be 0.000278 degrees. Now they told us only go to 4 decimal places. So I have 256 degrees plus 0.2 degrees from here, plus 278 degrees. If I add all that up, I have 256.200278 degrees. We're only going to go to 4 decimal places. We're going to cut it off there, so we've got to round it up because the 7, 256.2003 degrees. That is a conversion from degree, minutes, seconds to degree decimals. I was really glad I didn't have to do that in my head while I'm trying to drive the car. Actually, I was given degree decimals. I would have had to convert to degree, minutes, seconds. So thank you, Garmin, for having that feature in your GPSs. Now we have 90 degrees, 30 minutes, 600 seconds. So we'll look at 30 minutes times 1 degree for every 60 minutes. That's 0.5 degrees. Then we have 600 seconds times 1 degree over 3,600 seconds, and this looks like a 0 there. And so that comes out to be 0.1667 degrees. So we'll have 90 degrees plus 0.5 degrees plus 0.1667 degrees, or 90.6667 degrees. That's it. Feel free to pause. I'm going to go ahead and move on. Example 4, determine the value of the given trigonometric expressions. And given the value of another trigonometric expression, round off answers to 4 decimal places. So we're going to find cosine if secant theta is -7/4. Well, cosine theta is going to be 1 over secant theta because they're reciprocals of each other, which is 1 over -7/4, which is 4 over -7. And as a decimal, that'd be -0.5714. And the next one, find cosecant theta if sine of theta is -1/5. Well, cosecant theta is 1 over sine theta. So that's going to be 1 over -1/5, and that's going to be -5. Okay, next one for example 5. Determine whether the following statements are true or false. Use a graphing calculator when necessary. If cosine of theta is 0.96, then secant theta is 1 over 1/24. So the question is 0.96 equal to 1 divided by 1 and 1/24? That's the real question. Because cosine is 1 over secant, or secant is 1 over cosine. So they're reciprocal relationships. Let's see here. 0.96, is that going to be equal to, we have 1 over, that's going to be 1 times 24 is 24 plus 1, 25/24. So it's 0.96 equal to 24 over 25. And we can plug it in a calculator. We can look at 0.96 is 96 hundredths. But the answer is 0.96 equals 0.96 then. Yes. So if cosine of theta is 0.96, secant theta is 1 and 1/24. Okay, a mahi-mahi. Who likes to fish? A mahi-mahi is hooked on 70 feet of fishing line, 10 feet of which is above the surface of the water. The angle of depression from the water surface to the line is 40 degrees. How deep is the fish? So we have the water here, and let's see, let's put our boat here in black. Now out of the back someone's got a fishing pole, and it's got a line that goes down to the water. 10 feet of the line is up here. That means 60 feet down below the water. Now below the water we have a fish hooked on there. I'm not sure what a mahi-mahi looks like. I'll draw a swordfish. Fins here. Okay. There, whatever, there's my fish. And we also know that the water surface, this angle of depression is 40 degrees. The question is, how deep is the fish? What is our depth? So that's our big question. How deep is that fish below the water? What we're dealing with is basically a triangle. This side is 60 degrees. This is 40 degrees. We want the opposite side. We want that depth. So which function is going to deal with, here's our angle, the side opposite, and the hypotenuse? Which function deals with that? It would be sine. Sine of 40 degrees equals d over 60. Not degrees, this is feet. Hey, we can solve this equation. This is our unknown. So sine of 40 degrees equals d over 60. Let's multiply both sides by 60. So 60 times sine 40 degrees equals d. So d must be what? And this is degrees, it's not radians, so make sure your calculator is in degrees for this one. The depth is 38.57 feet. So again, what do? We set up do a little drawing. The angle depression means that's how that line's going down into the water. So from the surface, 40 degrees. You know, it's going 60 feet there. Gives us this right triangle, 40 degrees, 60 feet. We want D. It's a sine situation. We set up our equation. We multiply by the denominator, solving for D. Plug it in the calculator, 38.57 feet. Okay, this next and last topic of this section is surveyor tips. So we have this relationship, these two triangles, one triangle is within the other triangle. And they have these sides kind of in common. This one cuts off early, so these two sides there. This is the height, or h typically for height, but doesn't mean vertically. X is the distance there, d is there, so the whole distance for that one side's x plus d. Angles alpha, angles beta. We have this relationship. H would be d, that d down there, times tangent alpha times tangent beta over tangent alpha minus tangent beta. H could also be, you can manipulate this, work it around to where h is d over cotangent beta minus cotangent alpha. So using using this knowledge here, we're going to work on this problem. The surveyor wants to find the width of a river without crossing it. He sights an abandoned tire on the opposite bank, and the banks are straight and parallel. So I'm going to scroll this up and I can draw a nice picture and give us room to work. So here are the banks of the river, and there's water flowing through it. Okay. So on the opposite side, maybe I should have those banks in green. Let's see how it's green because of all the vegetation along the bank. On the opposite side, there's a tire. If I was real creative, I'd write Goodyear on here, but I'm not going to. Okay. Measures an angle from where he stands relative to the shore to be 31 degrees. After walking 15 feet away from the tire, he measures the same angle to be 13.5 degrees. So here's the tire. He's standing here. Okay. And he sees that and he measures the angle from where he stands relative to the shore to that tire to be 31 degrees. Then he walks away 15 feet. And he sights it in again, the angle of that tire. And this angle comes out to be 13.5 degrees. And this is x, the distance across the river. We don't know what x is. And we don't know what h is here. So we want to know what x is. That's our ultimate goal. So we're going to go with our second formula here. H would be equal to 15, that's d, that's the distance he's walked back, over cotangent of beta, and our beta is the 13.5 degrees, minus cotangent of alpha, and the alpha was the 31 degrees. And if you want to work this out a little bit, that's 15, basically tangent of 13.5 degrees. The TA89 does have cotangent in there, but not everyone's going to be using the TA89. It's not easy to get to it. Oh, I'm sorry, it's 1 over tangent. 1 over tangent, 13.5 degrees, minus 1 over tangent, 31 degrees. So 1 over tangent 13.5 works out to be 44.1653. 1 over tangent 31 is 1.6643. So our h is going to be 15 over 2.5010, which is 5.9976. And if you round it off, you're going to be at 6 feet. So all that tells us is h is 6 feet. H is 6. We still need to find x down here. How can we get x? Well, now think of it this way. We have a triangle where the angle down here is 31 degrees. The opposite side is 6 feet. And down here is x. Which function, and this should be more vertical, it's a right angle. Which function is going to deal with the opposite side and the adjacent side? Tangent 31 degrees is opposite, which is 6 over x. If I multiply both sides by x, I'm going to rewrite this. Tangent 31 degrees equals 6 over x. So if I multiply both sides by x, I'd have x times tangent 31 degrees equals 6. And I still want x by itself, so I'm going to divide both sides by tangent 31 degrees. This divides out. So x equals 6 over tangent 31 degrees, and x is 9.99 feet. So you could probably round that to 10 feet, but I'm going to go with 9.99 feet. I would take 10 feet on a test though. Okay. And that is our distance across there. So to recap, we're using this tool up here. We start at this point, it measures going over there 31 degrees, comes back, measures again 13.5 degrees. He's able to come up with this structure, so then he can apply these formulas, get our h, go back and get our x. And that does it for 6.2. Thank you for watching.